get that money, 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 money. I don't come the money, 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 money. Do it all for money, 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 money. Let me stack that money, 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 money. Come and get that.
All right, Junior Cert 2024 paper, ordinary level. I'm not sure if I'm going to split this into multiple videos, like for ordinary and higher, or just do one big one. Anyway, we'll see. So let's just get on with this. Yeah, good luck to anybody doing this tomorrow or at some time in the future. Yeah, I think you're going to do fine on this, most people. Okay, now, first thing I've noticed is I actually don't have a calculator, but whatever, probably won't need it. So this, let's just go through a few questions. I'm not sure if I'm going to do all of them, probably not. But here, this is calculator, put these numbers and operation into the calculator, it'll spit out the right answer. So if you do this, you should get 931. Okay, 931. That's a terrible color for, there we go, that's a bit better. So that's just a calculator job, all right. Cool, we move on. This, so 6 times 4 is 24, 6 times 8 is 48, so this should be 28.8. All right, calculator, just put that in your calculator and press equals or EXE, whatever is on your calculator. Now this one, so we can obviously see, like here, there's one operator or operation, whatever you want to call it. Now here there's 2, and you also have the index here. So you really should do this in steps, okay? So the first thing you say that equals, so use your BIDMAS, BODMAS, PEMDAS, BIRDMAS, whatever you call it. So it's going to be 32 divided by, so you do the brackets first. Now really you could over elaborate on this, but which is probably what I'm going to do. So you just do the brackets, that's squared, and you can say that equals 32 divide, next is I, index or indices is the plural. So we're going to do that, shoot, that's actually 4, okay. And then 32 divided by 4 equals 8, and that is your answer. Here, complete the table to show all the factors, okay? So factors, that's important. These are numbers that we can multiply by whole numbers to make this target number, okay? So for 8, 1 times 8 is 8, 2 times 4 is 8. So they're the factors of 8. In other words, you can rephrase this in a million different ways. These are the numbers that divide evenly. I don't like the use of the word evenly, but because even in maths is a number that can be divided by 2. Anyway, they're numbers that can divide into 8 and there's no remainder, okay? So for 12, well, what numbers divide into 12 and there's no remainder? So 1 and 12, obviously. I'm going to put it in order. So I'll just put them in order. 1, 2, 3, 4, 6, and 12. Now, you might not know them in order, that's fine. So just think, what are the numbers that multiply to give us 12? So 1 times 12, 2 times 6, 3 times 4. If you're very stuck, just go to your calculator, put in 12, and then divide it by a series number. So divide it by 1, your answer will be 12. Divided by 2, your answer will be 6. So your answer here would be 12. Divided by 2, your answer will be 6. Divided by 3, your answer will be 4. You can divide it by 4 if you want. Your answer is going to be 3, even though you've just done that already. Now, when you go to divide it by 5, you'll get 2.4. And that is not a, well, it's not a whole number and it's not a natural number. So because we have a remainder, so 5 would not be a factor, okay? That's if you're really stuck, but you at this stage you really should know the factors. 16, so we're going to have 1 times 16. Okay, now you don't have to put these in order. It doesn't, does it say? It doesn't say you have to put it in order. Okay, so if you don't put them in order, they should not penalize you for that. So don't worry about putting it in order. Whatever, 2 times 8, and then we just have 4, because 4 times 4, isn't it? 4 times 4 is 16, so we don't need to put in 4 twice because 4 is the same number as 4, okay? And that's it. Okay, 1 times 16, 2 times 8, 4 times 4. So this is just rough work over here. You don't, well, whatever. If you really wanted to do that, if you were stuck, you could do it, but I think most people won't do that. And that's it. You don't need to do this, just to be clear. Okay, what is the highest common factor? So what's the largest number that divides into 8, 12, and 16? Okay, so there's one goes into every number. So that definitely works. I better not put a tick here, just in case. I'll put a little star. So that definitely works. That's definitely an option. 4, does that go into 8? Yeah, 4 into 8 is 2. 4 into 12 goes 3 times. 4 into 16 goes 4 times. So that is definitely an option. 16, does 16 divide into 8? No. So that is not an option. Does 48 divide into 8? No, that's not an option. So basically, what's the biggest, the highest value between 1 and 4? So it's obviously 4. Okay, now if you didn't know that, you could do this. So you've got 8, we have 12, and we have 16. Okay, so another way of looking at it, what are the factors of 8? You've got 1, 2, 4, and 8. Okay, these numbers divide into 8 without any remainder. What are the factors of 12? 1, 2, 3, 4, 6, and 12. And then 16, what are the factors of 16? 1, 2, 4. We just listed these above anyway. So you could do this and you could say, what is the highest common factor? Well, what factors are actually common? Well, 1, 2 is common, 4 is common, and that's it. So obviously 4 is the highest common factor. So, I mean, there's so many different ways you could do that. Hope that makes sense. Lily buys the following ingredients. Okay, all this stuff. Work out the total cost of the ingredients. So you just add all these together. So you're going to get 249 plus 1.19. Now, I generally don't put the units or the money denomination, the currency denomination in until the end. But you need to remember to put it. It just makes things messy, in my opinion. So I don't do it till the end. All right, the best thing to do here is to use your calculator. So have one here. Now, if you didn't want to do that, you could do it in your head, but that I would not advise that. Do it in your head, mental maths. So yeah, you kind of have an estimate. So 249 and 119 is 368. Plus 99 cent is 467. 115 is 582. €2 is 782, and then 55 cent is going to be 837. But I would advise you to do it on the calculator. 837. So double check on your calculator. So we'll do that one more time. But this time on this. So it's going to be 249 plus 119 plus what is it? 0.99 plus 115. And also sometimes we can make a mistake on the calculator, so it's good to have the estimate from your head. there you are, 837 over 100, or 8.37, so we're fine. But yeah, that's it. Now, later that week, Lily plans a menu for a full week and goes shopping, all right? So typically in Irish examination, they have a load of English here. They have like an essay when they should just ask the question, you know what I mean? It seems like the people who make these exams are like frustrated English literature writers who wanted to be journalists but never could be. They put in a lot of like filler use. We don't care if she's planning a menu or going shopping. We don't care. Just give us the numbers. Anyway, her bill comes to 72.63. She pays using one €50 note and two €20 notes. Work out. So work out, you have to show your workings, how much change she receives. So how much money does she actually have? So you can label this whatever way you want. So whatever, you could say she has what? So she has €50 note. Actually, let's just not write down the euro because it's cleaner like this. And she has 220. So 50 plus 20 plus 20. Do it on your calculator, but you're going to get €90. Okay. So she has €90 and the bill is, what a cool name bill will be actually. That is a cool name. I'm doing it again. I'm putting in the euro symbol. It's 72.63. Yeah. All right. I'll just put in the euro symbol. 72.63. So the change is obviously going to be 90 minus 72.63. Now you can put that underneath it if you want, like this. Totally fine. Doesn't matter. And you can do it out. It's whatever way you like, but as long as you made it clear. So just what the change is this. You don't have to put a colon for this either. You can put equals or an arrow, or just make it obvious what your line of logic is. So what's this going to be? It's going to be 1737, is it? Let's do it on the calculator anyway, just to be safe. So it's going to be 90 minus 72.63. Yeah, so it's 1737 yo-yos. Okay, and that's it. 1737. We're good. Let's move on. Lily works as a chef in a restaurant. Okay. All right, she gets €18 an hour. She works 7 hours Friday, 8 Saturday, 6 Sunday. How much in total did she earn? So here we go. Let's just do this. How much in total did Lily earn for working on Friday and Saturday? Now this is very deceiving, guys, because if you see the word total, immediately you think, oh, it's Friday, Saturday, and Sunday, right? But it's not. They're just looking for Friday, Saturday. So I don't like the use of that word total. That's going to put a lot of students off. So watch out for stuff like that. Because to me, when I see total, it's just like bang, bang, bang. So just make sure you read the question, even though I was giving out about this bit at the start. Make sure you read it. How much in total did Lily earn for working Friday and Saturday? So Friday and Saturday. Now, you can split it up into two separate calculations if you want. Whatever. Or you can just do it as one like this. So it's going to be Friday and Saturday. So it's going to be what? On Friday, she worked 7 hours and got paid €18 an hour. And then on Saturday, she worked 6 hours and got paid, 8 hours, excuse me, and €18 an hour. Okay. So you do put that in your calculator, you get the answer. So 7 times 18 is 126. 8 times 18 is 144. Oh, wow. So it's 270. Okay. Or the alternative, you could have said total hours. So the total hours for Friday and Saturday is 7 plus 8, which is 15. And then, so you just say total, well, it says earnings, right? I'm just going to call it pay. Total pay is 15, because it's 15 hours times 18, and that's going to be €270. Okay, so like over here, I'm just going to write that down. Total pay with that weird looking P. I'll just rewrite it. Total pay. So just make sure it's obvious. So that's it. So you can say in a couple, or you can express that calculation in a couple of different ways. So it's €270. Okay. Lily is paid 50% extra for working on Sunday. How much does she earn for Sunday? So there's a few ways to do this. I think the way most students would do it would say 50%. So 50% extra. So what is 50% extra? Well, she works 6 hours and she gets paid €18 per hour, right? Equals. So 6 hours and she gets paid €18 an hour. But we have to get 50% of that. So it's just multiply by 50%. And you should get €54. So that's 50%. So Sunday pay, the Sunday pay then would be, it'd be the normal rate, which is 6 times, because it's 6 hours times €18 per hour. 6 times 18 plus the 54, right? So, because that's the extra. So when you do that, you should get €162. Now, I'll show you a couple other ways to do this for people that are interested. If you're not, that's fine. You can skip ahead. 50% extra. So in other words, if you're normally, what you get is 100%. If you get 50% extra, then you're getting 150%, aren't you? So you could just say the Sunday pay equals, so it's 6 hours times 18 times 150%. You could say that and you'll get the same answer. Or you could say, I'm not rewriting this every time. All right, let's see here. Right, so there's another way to do it. All right. The other way to do it, I'm going to show you 2 more ways perhaps. Another way to do it, well, it's 50% extra. So if you're earning €18 per hour, yeah, what's 50% extra? Well, 50% of 18, half of 18 is 9. So you're going from €18 an hour to €27 an hour, 9 more. So you could say it's 6 times 27. Or if you're working, she's working 6 hours, right? So 6 hours, well, if you're working 50%, you're getting paid for 50% extra. So 50% of 6 or half of 6 is 3. So you're going from 6 hours to not technically 9 hours value. So you're going 9 times 27. All of these will be equal to 162, okay? So I don't know why it's going out weird like that, but anyway, that's it. It doesn't want to highlight. But that's it, it's 162, okay? So there's a few different ways. Lily's gross income was 1,900 last month. She pays tax at 20%. What's her gross tax? So her gross tax, so gross is before any deductions have taken place. Gross tax is 1,900 times 20%. Yeah, so that should be about 380, not about 380, should be exactly 380, because yeah, at 1/5 of this is 380. Now, her monthly tax credit is $312.50. So that's the amount of tax she, how would I word this? You can get really technical on this, right? That's, if you want to think about it, that's the amount of tax she gets back Now, I don't think that's actually how it works, but basically you can think of it like that. Or that's how much of the tax actually she gets to keep for herself. It can't be taken away from her. All right, if you kind of think of it like that. So her net income, that's what they're looking for. So your net income is your income after all deductions have taken place. Now there's a couple of different ways to do this. I'm not going to go through a couple. I'm just going to do it one way. Net income equals. So it's your it's your gross income. Gross income minus gross tax. As I said, there's a few different ways to do this. If you want to do it your own way, that's totally cool. I might do it a different way myself. Anyway, gross tax and then plus tax credits. Credits. So another way to do it would be to take the tax credits away from the gross tax and then take all of that away from the gross income. Anyway, okay, so let's work out the net income. So the gross income, which we were actually told here, was 1,900 euros. So that's 1,900 minus the gross tax, which is 380, plus the tax credits, which is 312.5. All right, so when you do this, you should get 1,832.50 euros. So 1,832 euro 50. So next one, so we're on to sets. So write down a subset of A that contains 4 elements, okay? So basically you can choose any of these elements in A. So just make sure you have the set notation, the curly brackets. So I'm just going to go 4, 5, 9, 10. 4, 5, 9, 10. Now, how many other ones could you have? So that's fine, question done, okay? Now you could have put whatever, you could have put the last 4, 5, let me just do that again. 5, 9, 10, 11. You can have any of those 4, okay, etc., etc. So yeah, there's 5 there, and you can choose whatever way you like. Cool. So I think there is actually 5 in total. 5 choose 4. Yeah, there's 5 different combinations. All right. Write down a subset of A that contains only prime numbers. So it says a subset, okay? So, and it says only prime numbers. So it doesn't say all the prime numbers that are in it. So you could put down this. Well, what's a prime number here? Well, 4 is not prime. 5 is prime. 9, no. 10, no. 11, yeah. So you could just have 5 like that, which is totally fine. You could have 11. It doesn't say all the prime numbers, you know what I mean, that are in it. Or you could have 5 and 11. So these are also fine. But you only have to, it says a subset, so you only need one of these. A restaurant has a choice of rice or fries, which go with the main course, all right. So 5 people are choosing whether they have rice or fries with their main course. From the diagram, what did Aileen choose? So Aileen is here. They're telling us fries is F. So obviously Aileen chose fries. All right, tick a box which is correct. All right. Correct box in which Dara lies. Well, where is Dara? He's here in the middle at the intersection. So this is rice, but not fries. This is rice and fries, and this is fries but not rice. So Dara obviously is at the intersection, and this is the intersection symbol. Done. list the elements of the set fries and what you can, but not rice. Okay, you can say excluding rice, whatever. So who chose fries but not rice? So let's have a look. Yeah. So these guys chose fries. These guys chose fries and rice, and Lillian didn't choose fries at all. So these are not included. So it's just Evan and Aileen. So list the elements of the set. So it's Evan. It's A-N that he has, right? Yeah, and Aileen. Evan and Aileen. Now, if you really want to put it in set notation, we can do that. We'll just put it in a set just to be safe. Cool. All right. So we'll just look at the way they presented that here. So as I said, there's 5 different ways of doing the first one. 5, choose 4. There's 3, any one of the following for that. Here, fries only. And here, or intersection F, Evan and Aileen. You could have Aileen and Evan, doesn't matter. All right. So let's go back to where we were. So it does say fries only here, but she just chose fries. So I did say fries only in the answer, but fries is accept. I'm sure they accept fries. Accept fries without only. Yeah. Cool. Right, so we got that. Now here, all right, a summer camp has 2 water sports on offer, kayak and surfing. As usual, an English essay to start off a maths question in Ireland. In total, 24 students were on the summer camp U. That's the universal set. 15 had kayaked before, 8 had surfed before, 5 had kayaked and surfed. Okay, great. So we just have to fill the Venn diagram. So there's 24 in total, right? So we have 8 here. Why is that turning so gigantic? Let me see. Maybe I need to reduce the size of this. Yeah. So let's get back to it. So we have 8 and we have 15 and we have 3, okay? Now there's 24 in total, so we have to be aware of that. So let's fill this in. Now we're told that 5 students had kayaked and surfed. It's always good to start from the middle, so they will go in here at 5. 8 students had surfed before, okay? 5 and 3 is 8, that's fine. 15 had kayaked before. 5 and what makes 15? Well, this has to be 10. Now, just to show he did a bit of work, just do 15 minus 5 equals 10. So just show a bit of working. And then, so do we have everyone? We have 15 and 10 is 25, and 5 is 30. And 3 is 33, and yeah, so we're all good. Okay, so let's see, do we have 24? We've 10 and 5 is 15, and 3 is 18, but we've 24. So let's find out how many had neither kayaked nor surfed before. So just write down 24 minus 10 minus 5 minus 3, or as we said, 10 plus 5 plus 3 is 18, and we could take that away from 24. Anyway, when you do this, you're going to get 6. So we know 6 people did not do any of the activities before. I'll just put this in red so it stands out now. Great. One student is picked at random from the group of students. Write down the probability that this student has not kayaked it should be not kayaked or surfed before. It should be nor surfed, should it? Any English experts, should it be nor surfed? Anyway, so one student is picked at random. What's the probability they didn't kayak or surf before? So the probability of not kayak nor surf. Now, how would I write this? Probability. I'm just going to say, there's no point in writing it in a fancy way. Let's just write in probability. Probability equals, well, it's the probability, so it's the total people who have not kayaked or surfed. Well, who hasn't kayaked or surfed before? 6 over the total number of students, which is 24. Okay, so 6 out of the 24. And actually that is your answer. That's perfect. Now, in probability in mathematics, you do not have to simplify. So many teachers say that, tell the students to simplify, which is always good in maths, you know, always, well, actually I shouldn't say it's always good. It's 99.9% of the time it's the thing to do. But in probability, you don't simplify. So let's just simplify anyway. That's a quarter, isn't it? Which is fine. And that's also right. But look at this. 6 over 24 gives us more information because it tells us that there's 6 elements that have not kayaked or surfed before, or 6 people. And it tells us the total number of people is 24. With a quarter, we don't get any of that information. We don't know the total number of people. We don't know the number of people that didn't kayak or surf. You know what I mean? It just tells us the ratio between them. But actually, this gives us way more information, 6 over 24. Now, I'm going to see what the mark scheme said. Yeah, the mark scheme says 6 over 24 or a quarter. Now, teachers tend to say, oh, you have to simplify. You don't have to simplify. In probability, you do not have to simplify. And I'm not just talking about school, when you go do your maths bachelor's degree at university, or a maths master's, or a maths PhD. Anyway, let's get on with it. This is taking very long. Will I start skipping some stuff? Yeah, I'll just start skipping some stuff. Let's go do this coordinate geometry. Right. The points A and B are shown on the graph. Write down coordinates of A and B. Okay. So coordinates are like the alphabet. Okay. We have an X here. We have a Y. In the alphabet, what comes first? A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, Z. Yes? So X comes before Y. Okay, so you go along the X-axis first. So I always start at the center. It helps you. Start here, start at the origin. So for A, we go across 1. So the X value is 1. And then we go up 2. So the Y value is 2. 1, 2. For B, 4, 1. And that's it. Get your marks. Hence or otherwise. So hence just means using that information. Work out the distance between points A and B. So work out the distance between points A and B. Right. So I'm going to show you how to do that. Here you're going to use the distance formula. Okay. So the distance formula is, what is the distance formula? It's the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So that equals, well, what does that equal? It's the square root of. So I'm just going to rewrite this. So we're going to replace, we're going to get x2, we're going to get x1. So I'm going to leave them blank, plus and y2 minus y1. Now make sure you have the squares in, yeah? So what I'm going to do is replace, well, x2, x1. Let's call that x1, y1. And you can call that x2, y2. Okay, so let's do it. So x2 is 4, y2, or sorry, x1 is 1, y2 is 1, and y1 is 2. Okay, make sure you have that minus in. Okay, so let's do this. So that equals the square root of what? Well, that's going to be 3 squared, isn't it? Now you can skip lines if you're very confident. It's just that you can do this all at once if you want with your calculator. Okay, you don't have to put in every line, right? Because minus times minus plus 1 times 1 is 1. So your answer is going to be root 10. Did they give us units? Oh, they want 1 decimal. They want it to 1 decimal place. All right. So I'll show you how I do this. Root 10 is, with your calculator, I'll just do it here. Square root of 10. Let's clear that. Root 10. Shoot, that's actually 10. So make sure you put in the root. Root 10 is 3 point, I'll go to 3 decimals, 3.162. Okay. So we're told actually that's 3.162. ... Okay, now we have to get 1 decimal place. So what you do, because it's 1, it means you go to the first decimal point or decimal place. Okay, let me just reiterate this. So we're asked to go to 1 decimal place. All right, so 1 decimal place. So here. So what we have to do is we have to go to 1 decimal place after the decimal point. So we're going to go here. So here's decimal point. We go 1 decimal place. Go to the right. Now, what we do then is we look to the right and we see 6. Okay. Look to the right, we see 6. So that means 5 and above we round up. 4 and below we round down. So that's going to be rounded to 3.2 units. Cool. And that's it. Now, it did say hence, so that's, we've used the hence part, so we've done it. That's it. Now, it did say otherwise, so there is another way you could have done this. If you look here, you can see from A to B, we go across 3, don't we? 1, 2, 3. So we know that length is 3. And then we go down, how far? 1. This is a right angle triangle, isn't it? So to get the length, that's your hypotenuse. So you could say, if you wanted, whatever, you could call it H. So you could, or D, let's call it D for distance, it's even better. So you could say that's D. So if it's a right angle triangle, the hypotenuse squared, D squared, equals the other 2 sides squared. 3 squared plus 1 squared. It's just Pythagoras' theorem. C squared equals A squared plus B squared. You know what I mean? So then you could say D squared equals 9 plus 1, which is 10. So D is equal to root 10. So that's what the quadratic form, or the distance formula is just Pythagoras' theorem. For points, that's it. Nothing magic. On the coordinate diagram below, draw the graph of y equals 2x minus 5 for -1. So x is in the domain -1 to 5. So in other words, they want x equals -1. So what way will I do this? So let's do it as a little, you can say x. There's a few different ways you can do this. You know, your teacher will probably ask you to do it with a table. whatever. I just say x equals minus 1. We're going to go x equals minus 1, x equals minus, or sorry, 0, because we're going up to 5. They're telling us we start at minus 1 and we end up at 5. So x equals 1, x equals 2, x equals 3. So it is a bit monotonous, you know what I mean? It's a bit repetitive. X equals 4, and then we finish at 5. Oh, x equals 5. They could have given us the whole page for this, couldn't they? So our graph, the line equation is y. I'm just going to put it here because I'm running out of space, but it's up to you, as long as it's clear what you're doing. So basically, we're going to replace x with minus 1, then 0, 1, 2, 3. That's what it's telling us all the way up to 5. Start at minus 1, end up at 5. So let's just do that. So I'm going to do this. Y equals 2 bracket. I'm going to put the value of x in here, minus 5. So what I'm going to do is I'm just going to put this in red. No, actually, I'll tell you what I'll do. I'll get rid of these first. Now I'm going to put this in red. Okay, so that's in red. I'm going to copy that. So literally, I'm going to replace x with minus 1 in a bracket. So there we go, minus, okay? And then that's going to give us a value. And then for the next one, I'm going to do the very same. And the next one, I'm going to do the very same. So literally, we're just going to set up the equation. And we're just going to repeat the process. So, yeah, I mean, if you know what you're doing, this is quite an easy question, but it is very long. It is very long. I will concede that. So we're going to, with the next one, when x is 0, we're going to replace x with 0 in the brackets. And then here, 1, 2, 3. You'll see a pattern emerge here, by the way, 4 and 5. Okay, so just put that in your calculator. 2 times minus 1 is minus 2. Minus 5, that's going to give us, I'll put it in red. That's going to give us minus 7. So y is minus 7. Here, 2 times 0, 0, minus 5, that's minus 5. But you can do this on your calculator. That equals minus 3. That's minus 1. This is 1. This is 3. And this is going to be 5. Okay. Now what I will do is I'll put these guys in black so you can actually see what's going on here. But these are just our y values for the equivalent x value. So when x is minus 1, y is minus 7. So our actual point, now you can do this in a table, that's fine. Minus 1, when x is minus 1, y is minus 7. That's all that is telling us. So we have a point on the line. Here, when x is 0, y is minus 5. When x is 1, y is minus 3. When x is 2, y is minus 1. When x is 3, y is 1. When x is 4, y is 3. And when x is 5, y is 5. So the pattern is we go up by 2 each time, okay? That's because of the 2 in front of the x. So let's just plot these. So that it is a bit of work there, you know what I mean? But once you get the hang of it, you got it. So minus 1, minus 7. So there's minus 1. Now minus 7, wow, is down here. So our first point is going to be here. So next point is going to be 0 minus 5. So here. Well, if we start here, 0, we go across 0. We don't go across, we just go down 5. 1 minus 3. So across 1, down 3. 2 minus 1, across 2, down 1. 3, 1. 4, across 4, up 3. and then 5, 5, across 5, up 5. So let's see now. So we have to draw the graph. So let's do it. So it should be a straight, it says it's a line, so it should be just a straight line, and it is, boom. And that's it. I'm gonna take off the, well, I'm gonna take off the arrows. So that's that. And that's it. Alrighty. Just make sure you have your points marked in. Now here, they said, here's the equation of a different line, L. Write down the equation of another line that's parallel to L. Parallel to L. So if it's parallel, it means the slope is the same, right? Same slope. Same slope. So in other words, well, something in the equation is going to be the same. Well, this is of the form y equals mx plus c. So here, m is 3 and c is minus 2. M is the symbol for the slope. C is the y-intercept. It's where that line crosses the y-axis. So up here, you can see the line crosses the y-axis at minus 5. So you would expect minus 5 to be the y-intercept. And it is. And here the slope is 2. Okay, so that's a different line, but it's just an explanation. So here, well, if it's parallel, the slope has to be the same. So m has to be the same. So we already know m equals 3. That's for sure. So let's write down the equation of a line that's parallel. So it could be y equals 3x plus 1. Another one would be y equals 3x minus 1. Another one would be y equals 3x on its own. Y equals 3x plus 1,000. So basically, as long as the number beside the x is the same, we have the same slope. And just make sure the y-intercept is different. The only wrong answer you could put here when you have 3x is like y equals 3x minus 2. Do not put that in. It has to be a different line. But the slope obviously is the same. Same in each case. Slope is 3, slope is 3, slope is 3, and then so on. And that's it. Ain't nothing to it but to do it, as they say. Now, here, let's go. Write down an equation of another line that crosses the y-axis at the same point as L. Now, it crosses the y-axis at the same point. That's our y-intercept, which is C. So we know C equals minus 2. Okay? That's for sure. So our line is going to be something like y equals something minus 2. So we just have to pick another line. So you might be wondering, like, what is going on here? So here, this is basically what they're telling us. You have the x and the y axes. I actually could have left those arrows in, and it doesn't matter. We're going to have the x and the y axis. So basically, we have a line here that it's going to cross we're told it's 3x minus 2. So 3x minus 2, it's going to look something like this. Okay, that's our line. So I'm going to just call that y equals 3x minus 2. So this is y equals 3x minus 2. So what we care about at this point is that it crosses the y-axis at minus 2. That's why it's 3x minus 2. Now, there's infinite other lines that cross at that point, okay? So you could have a line like, like this, crossing that. You could have another line like that, crossing it. So there's like so many different lines, but they're all crossing at y equals minus 2. You know what I mean? So the only difference here is that the slopes are different, isn't it? So let's just do any line with a different slope and it crosses at -2. So we could say what? We could say 4x minus 2. That slope is 4, isn't it? You could say y equals minus 4x minus 2. You could say y equals a third x minus 2. You could say pi x if you want. Anyway, whatever. Y equals 50x minus 2. The whole key is that the y-intercept is the same in here. In the previous one, it was the slope that I don't know why it's weird here, but in the previous one, it was the slope that was the same. You know what I mean? So yeah, here is, I don't know why it won't let me highlight there, but yeah, it must be like a Bermuda triangle or something over here. It doesn't let me highlight it. Anyway, that's it. Cool. Right, how many more of these am I going to do? Will I do this? It's Pythagoras' theorem. All right, let's go at it. Question 11. You have a flower bed English essay as usual in the Irish exams. For some reason, Irish maths exam. All right, the diameter of the semicircle is 10 meters. Great. Write down the length of the radius. Well, the radius is half the diameter, isn't it? So R is 5. And we'll just put M for meters. Cool. Use the formula length equals pi R to find the length of a semicircular arc. All right, so pi R equals, well, it's pi times 5, isn't it? We just figured out R. So that equals 5 pi. Now they did say to us, give your answer to the nearest meter. So they want us to go into decimals then, right? So let's do that. On your calculator, put that in. It's going to be around, what is it? 15.7, something like that. So let's go. It's going to be pi. I'll do it on the calculator here. How about that? So literally put in, God, where is this on this? Oh, it's down here. It's going to be shift pi times 5 or 5 pi, whatever. It doesn't matter. 5 times pi. All right, 5 pi. SD 15.70796. Okay. All right, so it's 15.70796 ... Now, we're told to do it to the nearest meter. Well, where are the meters? This is 15 meters. These are decimals of meters. So the nearest meter is going to be here. Okay, look to the right. It's 7. Do we round up or round down? 5 and above, we round up. 4 and below, we round down. So it's going to be 16. 5 goes to a 6. 16 meters. Done. All right. Use Pythagoras' theorem to find out the value of x. Okay. So Pythagoras' theorem, write it down. C squared equals a squared plus b squared. Okay, first step to success. Then we're going to, well, we have this. We need x, yeah? So do we know the hypotenuse? So here's the hypotenuse, isn't it? Isn't this the hypotenuse? So again, we have these stupid arrows. So, well, they're not stupid, it's just that we don't need them. So we have the hypotenuse, which is 10. What letter symbolizes the hypotenuse? It's C. So that's our C. And A and B, so remember C squared equals A squared plus B squared. These are in your tables, all right? So this is C. A and B, it actually doesn't matter. Call that A and call that B. All right, so let's do it. So C is 10, A is X, and B is 5. So let's do that. So 10 squared equals X squared plus 5 squared. Okay, C is 10, A is X, B is 5. So you're going to get 100 equals x squared plus 25. So you bring the 25 across, you're going to get 100 minus 25 equals x squared. So you're going to get 75 equals x squared. So root 75 is equal to x. You do that on your calculator. Well, we know root 81 is 9, so it's going to be a little bit less than 9. So it's 5 root 3. If you do, well, I'll do it here, look. Root 75. Oops, a daisy. How do we go back on this? I just have to redo it. Root 75. God, I did that again. Root 75, 5 root 3, yeah, which is 8.660. Okay, so let's just write that down. So 8.660 is equal to x. Now, we have to do it to one decimal place. So the way I do it, your teacher might do it differently, it's fine. We go to the first decimal place after the decimal point. There's the decimal point. First decimal place is 6. We look to the right. It's another 6, so we round up. So we're going to say 8.7, is it meters? Yeah, 8.7 meters is equal to x. And that's it. Boom. Alrighty. Now, I'd always put that implies. This is an old school thing. It's like grammar in maths. It just connects. You don't need to worry about it if you don't know what it is. That implies, or that means. It's a way, it's like, yeah, connecting words. Well, that's it. All right, here we go. Trigonometry. The angle A is marked in the diagram below. All right, so here's a, write sine A as a fraction. Well, sine A, let's do this SOHCAHTOA, or silly old Harry, what is it, caught a herring trawling off America. I prefer SOHCAHTOA, so I'm going to go with SOHCAHTOA. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Sine, opposite over hypotenuse. Okay, well, where's the hypotenuse? This is the hypotenuse, isn't it? Yes. This is the hypotenuse. Opposite. What side is opposite A? Well, look down that way. It's this. This is going to be your opposite. Oh. And then I'm going to put up, actually. You're up. I have a lot of ups in school, actually. But let's not get into that. That's up. And then adjacent is going to be here. Adjacent. I'm actually going to call this HYP. How about that? Hype. So hypotenuse, opposite, adjacent. So sine is opposite over hypotenuse, which is 5. Yes. Over hypotenuse, which is 10. Cool. Done. Hence, find the size of the angle A. So when you're asked to find sides of angles, you're going to use sine inverse. You're going to use cos inverse. Or you're going to use tan inverse. Okay? So let's just write down what we have. We know sine A equals 5 over 10. Now, the way you're going to do this, we just want the size of it. We just want A. Okay? So we're getting rid of sine, aren't we? We're getting rid of sine. So how do you get rid of sine? You do sine inverse. So we're going to do sine inverse of the other side, which is 5 over 10. All right. The reason is this. Ready? If we do sine inverse of both of these things, we do the same thing to both sides. Sine inverse of sine, they cancel, so you're just left with A. But we never actually write that down. So, should I say never? You'll probably never write it down. So, yeah. So anyway, to get rid of sine, just do sine inverse of the other side. and that will give you an answer. Okay, so A equals, so sine inverse, I keep doing it on my physical calculator, I'll do it here. So shift sine 5 over 10, isn't it? So 5 over 10, and make sure you go outside that. Yeah, there you go, 30 degrees. So sine 30 degrees is a half. So your answer is going to be 30 degrees. Coolio. That's it. Will I go through all the, I just, I mean, I can't go, I'm not going to go through this all day. It's getting late here. And I want to do some of the higher level. But anyway, this one, there's a giveaway here, right? Well, for me, right, I'll just do it. So this is the way you're probably going to be, you know how to do it. You're going to do x squared plus 5x minus 24. I'll show you the long way and then I'll show you the shortcut. Anyway, so you're going to have x plus 8. They want, if this x plus 8 is a factor of this, that means x plus 8 can divide into that. So let's just do it. X times what gives you x squared? So that's what I would focus on here. X times what gives you x squared? It's x. X times x. Okay, so then just do it. X times x is x squared. X times plus 8 is plus 8x. Now, there's a few different ways to do this. This is how I do it. Some of your teachers will tell you just change the sign of the terms on the bottom, and that's totally fine. But the way I do it myself, I just take all this away. So I'd say x squared minus x squared, they cancel. 5x minus ax is minus 3x. And then we go here, next line, we're going to bring this down, minus 24. Okay, so x times what gives you minus 3x? We need them to match, so it's obviously minus 3. So let's do that. Minus 3 times x is minus 3x, funnily enough. Minus 3 times 8 is going to be minus 24. And then what we do is we're going to take the bottom line away from the top line. Minus 3x minus minus is a plus 3x. So minus 3x plus 3x, cancel. Minus 24 minus minus 24. That's minus 24 plus 24, cancel, 0. So your answer is going to be here. So the answer is x minus 3. That's the factor. X minus 3. Shoot, that's one of the worst x's I've ever done. X minus 3. Okay, now some of you mightn't have got that, so I'm going to do it the other way that your teachers might have taught you. This way works, but yeah, whatever. It's the same thing. It's the same thing, just written in a different way. So let's do it. X. Now there's actually 4 or 5 ways of doing this. I know there is. I'm not getting into it. I'm just doing it my way. I'm actually giving you one alternative here. A lot of teachers would say that's x and that's x squared. So they'd say x squared over x. That equals x times x over x. And then that cancels out. So the answer is x. So they put x up there. That's fine if you're used to that. Some people will latch onto that. If you like that, go for it. It will work. No problem at all. I'm just not going for it. Anyway, so you can do that. That's cool. But here's another way of doing this. So x times what gives you x squared? It's x. So you just have to get them to match up. So do it. X times x is, so this is going to be the very same as the last way we did with a twist. So it's x squared. X times plus 8 is plus 8x. Right? So this then is where the difference comes up. So a lot of teachers will tell you then, so remember I'd put the minus here. that just changes the sign of everything on the bottom, but it has that effect. Okay, it has that effect, but really what we're doing is we're taking it away. But your teacher will tell you, change the sign of each term on the bottom. So here is positive, it changes to minus. Here is positive, it changes to minus. But that's the same as just taking it away. You know what I mean? If you take something away, you change its sign. So do it anyway. X squared minus x squared, they cancel. 5x minus 8x, that's minus 3x. And we have minus 24. Okay, so again, we repeat the process. X times what gives you minus 3x is obviously minus 3. So let's do it. Minus 3 times x is minus 3x. Minus 3 times plus 8 is minus 24. So then we do this process again. I'll just make this blue. So we just do the process again. Now, as your teacher might tell you, change the sign of the terms on the bottom. So this is going to become plus, and this, you can't really see that, can you? This is going to become plus, and this guy is going to become plus as well. So do it. Minus 3x plus 3x, cancel. Minus 24 plus 24, cancel, 0. There's your answer again. Okay. Now, there is a quick way, if you have stayed with me, which is probably nobody. Actually, if you've stayed with me thus far, give me a hell yeah in the comments. Here is a fast way to do this. So if you're kind of, see, you don't have any of this stuff here, right? That literally, I wouldn't advise this, but whatever. There's a giveaway here. Well, look, ready? So we have an x squared here, yeah. I don't know why it keeps doing this weird thing. We have an x squared, we have an x. What do you multiply x by to get x squared? Well, the answer is x, isn't it? And then the last thing, we have an 8 here and we have a minus 24. What do you multiply 8 by to get minus 24? Well, what do you multiply 8 by to get 24? 3. So to get minus 24, minus 3. Boom. That's our answer. X minus 3, wasn't it? Let's go back. Let's go back in time. Wasn't that our answer? That was it. So look how fast it was to do it. Anyway, is what it is. Is what it is, as to say. And that's it. Right, I think I'm going to leave it at that. Thanks for staying with me, and good luck if you're doing exams.